Yeah, welcome everybody. I'm very happy that I can speak here today at the Agromek. It's my first time at the Agromek, and I am learning Danish, but I'm not there yet, so I apologize. I have to speak in English, else it wouldn't make any sense to you at all, I'm afraid. So Miriam is my name, Miriam Weissroth. I work for Lundsby, which used to be Lundsby Biogas. One or the other might know the name. It's now reformed to Renewable Solutions. And my background is water, actually. So I'm a soil scientist, and I've been working with water, every form of water, for I don't know, the last 20 years, and 17 years of that with heavily polluted and industrial effluents for a German company. I'm German, as you perhaps can hear. And I've been working with treating digestates and manures for 12 years. And I would like to give you some first impressions, what it's all about. The time is too short to go into detail, so if anybody should have any questions, we could talk later. But today it's just scratching on the very surface. So a few words about Lundsby, because that's the background. It's a Danish company. I'm sure some of you might know it. It's located not far from here, a bit up north in Luxembourg, and we're 50 people now and doing EPC contractors work in the biogas sector. And it's growing, as the whole biogas sector is, and as the project size is. So currently it's up to 500,000 tons per annum feedstock input for the plant size, and it's going up to 900,000 and 1 million the next projects. And because the whole biogas branch is changing, the need for the portfolio is changing, and this is why digestate treatment is now working its way into Lundsby, but into the biogas branch in general. But the question is what it's all about, because I'm sure many of you have heard about digestate treatment for many years. Actually, it's been around for more than a decade. So much research has been done on it, so much has been published, so much has been said on it, but very little has actually been done on it in real life, so to say. So the question might be, what is changing? Why should we focus it now? And when we look across Europe, a couple of things are changing compared to the last 10 years, because the EU nitrates directive, which is, let's say, the basic trigger for all actions around the digestate treatment, has been around for 30 years now, 25, I don't know, 90 something. So all that is actually, the roots are ancient, but what we see is changing now is we see across Europe that the legislation becomes stricter, and this is important, loopholes, so to say, around the use or reuse of fertilizers are being closed. So the nitrate directive or the implementation of that becomes stricter. That's one major factor. And of course, we have a biogas boom. We already heard a lot about it from my first speakers, but you all know it. I mean, before the Ukrainian war, we already saw that the biogas, renewable energies, were developing very fast. The Ukrainian war has given a huge impulse, I think. Being German, I can really say that, because we were the ones who depended most on Russian gas. So a lot is happening, and it's happening ever faster. And what we all can see is the projects are growing. So we have bigger biogas plants. We look more towards liquefaction these days. It's like a new world in the biogas sector that's developing across Europe. And of course, that means we have more digestate in one spot, and that creates new issues, so to say. And what we also see, I'm not sure about Denmark, but I know about some other European countries, more land is taken out of operation. So it's being reconverted to forests or to grassland, which means we have less land. So in the end, what's changing when we look at, how we've worked before, how have we dealt with excess P and N margins in the agricultural sector? we see things are sort of sharpening. We see more competition for land, because when you collect the waste, actually that's another point, we're getting more waste now into the plants as well, like industrial wastes. So when we have more digestate in a spot, it's of course a little harder to take it all back to the land, and we have longer transport distances. So something that's worked out for a long time in some regions across Europe becomes an issue, because you're not talking about, I heard 20, 30 kilometers transport distance. We talk suddenly about 100, 200 or more kilometers of a transport distance. And we talk about crossing borders, and you don't want to take digestate across a border. It's not much fun. So the centralization, so to say, brings new issues regarding the digestate. And what we also see across Europe is it's developing into an integral part of the permitting. So no biogas plant without a proper digestate concept. But I don't know, has any of you ever looked into the issue? If you ever Google or you read your agricultural newspapers, you are slain. You are slain by processes, you're slain by names, by phrases, and by promises. We can do it. So it's like our process does it. And it's a very confusing thing. So how do you approach the whole issue? Googling will probably just drive you crazy or despair, let you despair. The important thing is digestate treatment is not defined. So anything is digestate treatment. The moment you have a screw press, you have a digestate treatment. Come down to it. So if you look down that path, you'll have to find your own targets. You have to find out what do you want to have in the end, or what do you have to have in the end? Because if it's a case of the permit, it's not the question what you want, it's the question of what you have to deliver. So that might take you down to discharge to river. In any case, you have to define your aim, and then you see it's the input and the output. It's that and that which determine what path you have to take. And just as a very quick example, because I suppose solid separation is what most people are familiar with, it already shows in the very first stage of a digestate treatment process that depending on what you actually want to do, you need different machines. This is just giving you an impression. Don't nail me down on decanter or screw press or anything, because there's so many different ways on how to combine it. This is about, if I want to reuse fibers, let's say, want to have a pyrolysis, I want it probably dry. But if I need to take it to the river, I want the water from the solid separation clean. So I have a whole world of machines, of processes, of combinations, and I have to find the way that makes it work for me in the end. And that is not so easy. So if that's what we've got, that's what we know, then we see what we want, dry or perhaps clean. Then we have to accept that if I have it dry, my water fraction from the separation will be dirty. But if I get this really nice and clean, I have wet solids I have to deal with. So I have to compromise, and I have to be aware of that digestate treatment is also about compromising. And that makes it pretty complex. So this is what we know. We have our feedstock, our various feedstocks, we have the digester, and we get out a digestate, which of course is nice and homogeneous. So it's all mixed, homogeneous, and we know concentrations are somewhat higher than in the feed because we have the biogas losses or we have the conversion inside the reactor. And you also know that every digestate is different, you're aware of that, and they keep changing over time because our feedstocks change. So far that's been okay. But what you also have to be aware of, that our digestate is a mixture. Of course, it's water, and of course more than the small fraction. This is just to show you. And it's dry matter. But I found that many people are aware of the dry matter, but not that this consists again of dissolved compounds and particulate matter, which again consists of some organic phases and inorganic phases. And that is important to know and to understand when you go towards the digestate treatment. So we have to be aware of that. Digestate is a wild mixture of particulate matter, of solids. And here you all know we have a huge size spectrum. So if you think of straw fibers or fibers on the one end, and then we have a large amount of really fine particles in that. And this is where sand ends over here. So this is much smaller than sands. This is like the clay loam fraction. It's really fine particulate matter that we need to take out. And then we have organic material, we have salts, we have our nutrients, and perhaps we also have toxic matter in it, material that we need to take care of. And just to give you an impression what it is we need to look at when we talk about digestate treatment after solid separation. These are typical ranges for what we can find in a digestate, and this is a typical municipal wastewater. And it's not about going into details, but you see it's a different world. It's really, really dirty when we have to look at it as a dirty wastewater which needs treatment. And this is what makes digestate treatment often not so easy, or rather complex. I said before, the aim is very important. So it's the quality of what I've got in the digestate, and it's what I need to reach. And this is a typical example for a discharge to river. And again, it's not about discussing with you milligrams per liter. It's just getting ideas that we really, really have to do a lot of work before we can actually discharge to the river. Or perhaps, I mean, if we do all this work and put in so much energy and money, we might want to reuse it or resell it. Talking about products, resell the treated water. But it's a hell of a lot of work to get there. And I think it's probably easy to understand we will have to use several processes and different processes to get where we want. But how do you do that? I mean, finding concepts. We heard about finding concepts. So if you know you have to do something about it, you want to find your aim, your target, and then already with that, you want perhaps to define your products. What good can I get out of this effort I have to make? Then I'll define the process. Perhaps I need drying, perhaps I need some buffering, whatever. And then in the end, you come to a point where you get something like a capex. How much does it cost me, or the OPEX? And very often it's like, good gracious, I can never afford that. That is definitely much too expensive. So you take it back to the beginning, and you might go round in circles to get it right. But in the end, it's all about finding your solutions. And I really have to emphasize it's your solution that has to be found. And to get there, there are many, many ways. There are many processes and stages, and there are many process combinations which bear the most fantastic names. And of course, there is much, much more. I just threw some, on the screen to give you an impression that you have options. So after asking what's my aim, the next important question that is really, really underestimated is, can I reach my target? Because the combination and the different processes have different focuses, and I cannot always, with every combination, reach what I might have to reach. If I have to get it clean to river quality, and I have sharp requirements for that, not all of the processes might actually get me there. Reverse osmosis, yes or no? Not all of them get me there. So I have to understand, is that what I need really possible with the combination I chose, I would like to choose? And then we have all the questions around the fractions we create. What do I do with the solids? Can I take it to a pyrolysis? Can I not? Do I have to dry? Can I make pellets out of it? Can I use it? Where is my value in all of this? Because it's costs, of course, on the other side, but we want to get something out of it. Then practical questions. How difficult or easy is it to operate? What's the footprint? What's my logistics? So important for you is for digestate treatment, there is not one answer, but there is an answer, always. It just might take some time to find it. So coming to the end of my presentation, my message to you is that you know that every digestate is different and it keeps changing, and every path is different, and this is important. So if you read something, this is the solution, keep in mind everybody has different needs, so the path will probably be different. And this is why you cannot just Google CAPEX and OPEX for a digestate treatment plant. Of course you can get a CAPEX or a price for a decanter, and if that's your digestate treatment, you've got it. But the moment you start combinations, it's individual, and you have to find the best. And yes, it does cost money, but one thing is you also might expect revenues from the products. But more important is, if we look at these big plants and at the issues, why do you treat it in the first place? Why do you perhaps have to treat it? You will have costs for the logistics as well. If we take it a couple of 100 kilometers into the next country, or well, the Dutch sometimes take it even to Greece if they are desperate, then you have costs as well, and of course that you have to counter-calculate that. So whether it's a gain net or a net cost in the end, I cannot tell you right now. We have to find out, but there is a way. And remember, there is no the best solution. There is only your best solution when it comes to that. So there is a way. Let's do it. Let's find it. And that's all I have to say for today. Thank you for your attention.
Thank you very much.
Oops.
Do we have any questions?
So, slain. Always.
No questions at all.
Slain by a completely new matter.
It sounds like this is a very important part of the overall business case for a biogas project.
I think it will be for many future projects.
When you are working with this at Lundsby, is this being a regular part of the development of your projects, that you are looking into? What are we going to do with the digestate?
I would say a regular part is not yet the phrase, but it is coming, because depending on where you are located, Denmark, I think, is still pretty good, actually. So I think you are in a lucky situation that, as a rule, you can take it back to the land. But when you move further into Central Europe, that is not possible any longer. And as I say, it's becoming part of the permit. You don't get your permit if you don't have the solution. But we need the biogas, that's undoubtedly. Then it becomes an integrated part of the project. So I think the future sees more need for it, and we can see it in other parts of Europe coming, whereas Denmark is still quite good. But I understood the situation is changing over here as well, or up here as well, isn't it? So.
You have a question?
I'm from Holland, Dutch, and you said there isn't no best solution, but what solution, for example, will have the best opportunity to make from the Digestate? Is that, for example, a kind of fertilizers, liquid CO2?
Yeah.
What in what products have the best opportunity
Yeah,
for
I think
the future?
this is what I wanted to say. There is no the just best solution for everybody, but there is your best solution. And that depends on what the situation for your biogas project really is. I would say if I can take it back to the land within 20, 30 kilometers, the price, the costs for that is so low that you will not think about digestate treatment. So if you have that option, you don't treat it. You know, you transport it back. But we are looking at big projects in the Netherlands and Belgium where you cannot take it back because there is not the land, you know. So, and then you start to look at what have I got? For example, what can I sell? What is the market crying for? And then you see ammonia sulfate solution, for example, is like, stay away, I don't want it. Then you say, okay, I don't want to produce that because nobody wants to buy it or price is low. And then you say, okay, what do they want to buy perhaps? And then they say ammonia nitrate solution. Okay, you say, okay, I make that. So you sort of find an iterative way to evaluate your costs that you always have, because you don't produce ammonia nitrate for nothing. It actually costs quite a bit of money. So you only do that if it costs more to treat it. So, and that I can't tell you because it depends, for example, on the nitrogen concentration in your digestate. If you don't have manure in it or chicken litter, if you only have, let's say, farm waste, your nitrogen content might be around 1,000 or 2,000. And then I would never tell you, you recover the ammonia, because it doesn't add up, you know, it costs more to recover it than you get for the product. So I cannot tell you, standing up here now, which way you have to take, but I can help you to find the way by looking together at what is it what you've got and what is it what you've got to deliver. This is what I want to say. There is not one way, there are many ways, and it always, in the end, it's always about money, isn't it? What can we afford? And if we can't afford to treat it, pyrometin, if there's no business case, you don't have a biogas plant in that spot, end of story, you have to take it to another place. That might, yeah, I mean, that's the way it is, isn't it? In the end, it has to be a business case, but there are a lot of options to perhaps save the business case and get there in the end. It's just not the one answer. It's really complex. Yeah.
Any other questions? Okay, I have one quick one. With the recent rises in prices for fertilizer, have you noticed any changes in your international project development?
Yeah,
There,
of course,
there is
yeah.
more, because in Denmark we have seen much more interest for fertilizer from the
Yeah.
farmers, because the fertilizer is being expensive.
Yeah, of course. I mean, that's a fact. I mean, we all know that the fertilizer plants shut down production because the Haber-Bosch process was just getting too expensive. So the classical mineral fertilizers were out of stock. And yeah, of course, but you can see it's dropping now. So and that's a bit of an issue. So prices were increasing steeply and now they're dropping again. And that, of course, makes the calculation of a business case a bit of an issue. But I think you can still look at a long-term stable average and then assess costs for the production and make an educated guess or whether it pays off or not. I mean, that's, yeah.
Yes.
But it's a changing market and it changes really from day to day these days. And yeah. Fair enough.
Okay. One last question, or we'll maybe, yes?
Thank you for the explanation. The first thing, when you put up your processing, you took the water part, you end up with reverse osmosis. But by reverse osmosis, you still have a water. Reverse osmosis is giving two different flow.
It's hard to understand you.
Sorry.
Yeah.
Sorry. Reverse osmosis are giving two flows, one high concentrated and one clean.
Yeah.
So you still have a water.
Yeah. Yeah. This is what I said, you have to find solutions for.
In my opinion, there are much better water treatment systems which you could use. Microfiltration, you can use filter filtration and things. So there are much cheaper ways.
Yeah, but I think let's hop. I mean, as I said, there's so many different chains. I mean, you could. So wanted the pointer. That will be somewhere down here. As I said, there's so many different combinations you can use, and the reverse osmosis you only use when you have to get to certain treatment targets. I mean, you don't use any step without need. But if you want to get to certain requirements, there is no way.
That's not clear. You use reverse osmosis when you have a salinity, a high salinity. That is a way where you use it, and not to the other things. Because
exactly.
it's too costly.
Exactly.
Too costly.
Yeah, I'm fully with you there. Yeah.
That's one thing. The other thing is what you also asked about. That is in the situation now where we have a big, where we need fertilizer. The biofertilizer, you can say the biofertilizer market is racing. And at the same time, the chemical fertilizer is going a little down. So that means we have a market which is coming up where the filtrate part could be reused very easily. So there is a good market for you can say the rest.
Exactly.
That's also.
Yeah. I'm totally with you. Also with the reverse osmosis, it is not something you use unless there is a need for it. None of it. You only do this if you are, for example, forced to, because you're in a location where you have to, let's say, either sell it as processed water and have to really get out all the salinity, or where you have strict requirements for the river targets. I'm not saying we want that. I'm saying you might have to have it. I'm not in favor of any of this. Yeah, so I'm fully with you, and also with the revenues. And we see the market is changing. The good thing is that the legislation around the reuse of these organic fertilizers is now picking up, so you can actually sell it abroad, because that was difficult. So we see. I'm totally with you. Yeah, we see huge changes. But still, to produce an end fertilizer has costs, and you still have to reassess, is the amount of fertilizer I can produce worth compared to the costs for getting it. Yeah.
Thank you very much. I think we'll say thank you, and then we may try to find some lunch.
Yeah, and thank you. You sacrificed your lunch.